Alright, so in this video we go over section 5.5, polynomial and rational inequalities. So we have already done a little bit of polynomial inequalities in the previous chapter. However, the scope of that section back then was to limit ourselves to quadratic inequalities. So in this case we are going to extend the same idea to polynomials that are degree higher than 2, like in this case we have an inequality of degree 1, 2, 3, and 4. Okay, so keep in mind that this is repeated twice, counts as a degree 2, and these two other factors give rise to another 2 degrees. So the overall degree will be 4. All right, so how do we proceed to solve inequalities? Well, just the same way we did it with the quadratic inequalities. Change the inequality sign to equality sign, to equal sign. That is, turn the inequality into an equation. And we do that in order to find the zeros. X equals negative 3 over here, x equals 1, and x equals negative 5. And then we're going to plot these points in the number line. However, be careful, keep in mind that the inequality sign. In this case, we have greater than, not greater than or equal. So when we plot these 3 points on the number line, we are going to do so in the following form. I need another color here. It's right there. So we're going to plot these numbers from smaller to large. So that's going to be negative 5 first. And I'm going to put an open bubble here. And then negative 3. And then positive 1. Okay. Otherwise, again, keep in mind that if we had greater than or equal, then this would have been full bubbles. Okay, now what are we going to do with this? Well, as we did it in the previous section with the quadratic inequalities, this slicing and dicing this number line in these numbers, in these critical numbers, gives rise to 1, 2, 3, 4 intervals to test. So we need to test this interval. So what I'm going to do here is write every single factor along with its power right next to the number line. X plus 3, x minus 1 squared, and x plus 5. Well, I'm going to put parentheses. I don't need them except for the second one, but I'm going to write them all. And then we are going to choose a test value, a value that lies in between each of the intervals. For example, here I'm going to choose the number negative 6 is going to be a good interval a good number to test within that interval. All right, so negative 6. Between negative 5 and negative 3, I'm going to use negative 4. Between negative 3 and 1, the easiest is 0. And between 1 and positive infinity, I will just use 2. Alright, so now I'm going to put here the corresponding signs, and at the end I'm going to multiply the columns of the signs. Okay, so let's see what are we going to get here. So I'm going to plug in negative 6 over here in each interval. So negative 6 plus 3 is going to give me negative 3. I only care about the sign, which is negative. Negative 6 minus 1 is negative 7, but if we square, we get positive 49. That's a positive. Negative 6 plus 5, that's a negative number. The number negative 4, plug it in here. Negative 4 plus 3 is a negative number. Negative 4 minus 1, quantity squared. Well, because of the square, that's for sure positive. And the negative 4 plus 5, positive. 0 plus 3 is positive. 0 minus 1 is negative 1, but squared becomes positive. 0 plus 5 is positive. 2 plus 3 equals positive 5. 2 minus 1 is 1, and squared is positive. And x plus 5, 2 plus 5 is 7, which is positive. So now our job here will be to multiply the sign. So in this case, negative times a positive is negative times a negative is positive here. Two positives is a positive times a negative is a negative here. The product of all positives is positive. And the product of all positives is another positive. All right, now let's go back to our original question. So in our original question, we're looking for greater than 0, which means positive. So I'm going to highlight only the positive intervals. In this case, okay, I'm going to use the same color to denote this magenta color. So I'm going to shade only the positive intervals. All right, and then I'm going to write this using interval notation. So the solution set will be negative infinity to negative 5, union negative 3, negative 1, negative 3 to positive 1, union positive 1 to infinity. And that'll be an example. All right. Let's look at the next example. So for letter B, we're going to have x to the fourth power greater than x. So let's see, how do we proceed about this one? Okay, so number one, you want to make sure to have everything on one side of the inequality. So to do that, I'm going to subtract x to both sides of the inequality, and then I'm going to have x to the fourth minus x greater than 0. From here, I will factor out x. I'm going to start solving. Well, actually, first convert the inequality into an equation, and then solve the equation by factoring. So this is going to be x times x cubed minus 1. Okay. We are apparently done, except for we still need to simplify this difference of cubes. So by the formula of the difference of cubes, keep in mind that when you have a cubed minus b cubed, a minus b, a squared plus ab plus b squared. That's the formula to factor the difference of cubes. All right, so we're going to get this x times x minus 1 times x squared plus x plus 1. So from here, we're going to have that the critical numbers are x equals 0, x equals 1, and in this case, this will be the only two critical numbers, because if you try to solve this by factoring factors of 1 that add up to 1, it's impossible to have those. So it's no solution. In fact, if you try, okay, let me use a different color for this. Let's see, I'm going to use this green. X squared plus x plus 1. Try to solve that. So we use the quadratic formula. X equals minus 1 plus minus the square root of 1 squared minus 4 times 1 times 1. What are we going to get here? X equals minus 1 plus minus the square root of negative 3. What is that going to be? Complex numbers. So we don't want complex numbers. We only want real solutions for inequalities. Okay? So let's put this on a number line from smaller to large. So between 0 and 1, right? Oops. All right, let's see. Let me see, what am I going to do? So let me erase this here. And that's 0 and 1. Those are the critical numbers. And in this case, I'm going to write down the factors. In this case, I'm just going to write down the factors that gave us the zeros, not the third one in this case. X and x plus, x minus 1. Okay, these two factors, x and x minus 1. Now, I'm going to choose 1, 2, 3 values, test values. In this case, -1 between 0 and 1. I'm going to use 1/2, and between 1 and infinity, I'm going to use 2. And I'm going to get the signs for this. So -1, plug it in x. That's going to be negative. -1 minus 1 is also negative. Positive 1/2, plug it in x. That's a positive 1/2. 1/2 minus 1, that's a negative 1/2. 2, plug it in x, that's a positive, and 2 minus 1 is positive. So when we multiply the overall signs, that's negative times a negative, which is positive. Positive times a negative, which is negative, and the product of the positives is positive. So now let's go back to the original question. We want positive. So which intervals in this case are the correct ones? So the correct ones are going to be the ones with the plus. Okay. And our final answer, let's write it down using interval notation. So the first one, which is -infinity to 0 union with 1 to infinity. And that's our solution set for this inequality. All right, so let's look at the next page on the next topic, which is solving rational inequalities. So the way we're going to go about this is going to be very similar to those like the polynomials, except for the critical numbers that come from the denominator are always going to be open circles. So let's see. Let's first of all write it down in factored form. So I'm going to have x minus 1 divided by x plus 3 times x minus 3. So, number 1, we are going to have restricted values. Which are going to be x equals -3 and x equals 3. Can you see that? Here, x equals -3 makes the denominator 0. Here, x equals 3 makes the denominator equals 0. All right, so now those two are going to be placed over here in the number line strictly as open circles. And that's because those values cannot be taken. Even if you see the less than or equal, these are still open circles because they cannot be plugged in, because otherwise the denominator is 0 and then the denominator is 0 and the expression goes undefined. All right, now x minus 1, from here we are going to get that x equals 1 is the other critical number. So this one is going to have a full bubble. Okay. And let's draw the rest of the number line. And we are going to do essentially the same. We are going to write down the factors x minus 1, x plus 3, x minus 3. And I'm going to choose test values between each interval. All right. And in this case, those values that I will choose are going to be, let's see, -4, 0, 2, and 4. So I'm going to plug in these numbers. So -4 minus 1, it's still negative. -4 plus 3 is negative. -4 minus 3, it's even more negative. 0 minus 1 is negative. 0 plus 3 is positive. 0 minus 3 is negative. 2 minus 1 is positive, 2 plus 3 is positive, 2 minus 3 is negative. 4 minus 1 is positive, 4 plus 3 is positive, 4 minus 3 is also positive. So let's multiply all the signs here, okay? So to multiply all the signs, let's see what we get. Get the right color. The product of three negatives is negative. Two negatives is a positive times another positive is positive. Two positives is positive times a negative is negative, and all positives is positive. All right. Now let's look at the original statement. We want less than or equal, so that means the negative ones. Okay. Actually, this one right here, which is negative, and this one right there, which is also negative. All right, so let's write down using interval notation. So solution set, that's going to be negative infinity to negative 3 with parentheses because of the open bubble union. 1, but in this case bracket because we have a full bubble, to 3 in this case with parentheses. So again, be careful when it comes to rational inequalities. Even if you have the equal part, some of them are still going to be parentheses or open bubbles because those come from the denominator. Those are restricted values. All right, let's look at another example. Let's look at the second example, which is going to be 4x plus 5 divided by x plus 2 greater than or equal 3. So in this case, we need to be very careful with how we treat one example like this. We need to make sure that the right-hand side of the inequality is a 0. In order to get that, I'm going to subtract 3 to both sides of the inequality to get 4x plus 5 divided by x plus 2 minus 3. In this case, I will use the least common denominator in order to get a single fraction. So I'm going to multiply numerator and denominator of the second term by x plus 2 and divide by x plus 2. And that's greater than or equal 0. All right. So when I combine these together, I obtain the following. 4x plus 5 minus 3 times x plus 2 in the numerator divided by x plus 2 in the denominator. And then I'm going to simplify this. I'm going to distribute the 3 to get 4x plus 5 minus 3x minus 6 divided by x plus 2. That greater than or equal 0. I'm going to continue here. X's with x's for x minus 3x. That's going to give me x. And 5 minus 6. That's going to give me negative 1. And divide that by x plus 2. All right. That's still greater than or equal 0. So on the one hand, this guy implies that x cannot be negative 2 because otherwise the denominator is 0 and that will go undefined. Okay. On the other hand, I'm going to have another critical number of the form x minus 1 equals to 0, which means that x equals 1 is the other critical number. All right, so let's plot these two numbers on the number line. X equals 1 with a full bubble because we have greater than or equal. But the negative 2, since it's in the denominator, that's going to have the open circle. So negative 2, 1, and I'm going to write the two factors, x minus 1 and x plus 2. I'm going to choose numbers, test numbers to test. So that's going to be negative 3. I'm going to choose 0 in between, and I'm going to choose 2. And I'm going to do the following. Negative 3 minus 1 is a negative number. Negative 3 plus 2, that's also a negative number. 0 minus 1 is negative, 0 plus 2 is positive. When we plug in 2, 2 minus 1 is positive, 2 plus 2 equals positive. So when multiplying the signs, we get positive, negative, and positive. Now, in this case, again, we're looking for greater than or equal, which means the positive ones. Okay? The positive one. So in this case, I will shade these two right here. And the final answer to the inequality will be negative infinity to negative 2. And by the way, I forgot to put full bubble here. Again, keep in mind that came from the inequality sign. This one comes from the denominator to infinity. All right. Let's see. That's a solution set, and let's do the last of them. For the last of them, well, luckily almost everything is in expanded form except this x squared minus 36, which we need to, I'm going to leave some space rather. So x times x plus 6 times x minus 6, x minus 2, divide that by x minus 4 times x plus 3, less than 0. So this one is going to take a while. Okay? On the one hand, x cannot be 4 and x cannot be negative 3. So those are going to go with open bubbles. However, all of this in this case are going to go with open bubbles because we don't have the equality here. Had we had the equal here, well, only the zeros from the numerator would go with full bubble, and these two only with an open bubble. So from here we get the following: x equals 0, x equals negative 6, x equals 6, and x equals to 2. Those are going to be the critical numbers. This one is going to take a while. Okay, I need to write them from smaller to large. So negative 6, and then comes negative 3, negative 6, negative 3, and then which one is next? Negative 6, negative 3, then comes 0, and then positive 2, and then positive 4 and positive 6. All right, so this is how it's going to look like this time. It's going to be a little bit big. A lot of multiplications, or a lot of obtaining signs. And again, as usual, I'm going to write all the factors: x, x plus 6, x minus 6, x minus 2, x minus 4, x plus 3. And I'm going to choose test values between less than negative 6. Negative 7 is a good one between negative 6 and negative 3. Negative 4 is a good one between negative 3 and 0. Negative 1 is going to be another test value between 0 and 2. I'm going to choose 1 as a test value. Between 2 and 4, I'm going to choose 3. Between 4 and 6, I'm going to choose 5. So we also were lucky to have all of them integers and not fractions like we had to do on one of the examples. I think it was on the previous page, right? So let's go ahead and get those signs. Negative 7 is negative. Negative 7 plus 6 is negative. Negative 7 minus 6 is negative. Negative 7 minus 2 is negative. Negative 7 minus 4 is negative. And negative 7 plus 3 is negative. How many negatives do we have? 1, 2, 3, 4, 5, 6. That's going to give me a positive. Let's go with the next one. Negative 4 is negative. Negative 4 plus 6 is positive. Negative 4 minus 6 is negative. Negative 4 minus 2 is also negative. Negative 4 minus 4 is also negative. Negative 4 plus 3 is negative. So we have at least one negative and an odd number of negatives. I mean, at least only one, only one positive and an odd number of negative. This is going to be negative. Let's go with the next one. Negative 1 is negative. Negative 1 plus 6 is positive. Negative 1 minus 6 is negative. Negative 1 minus 2 is negative. Negative 1 minus 4 is negative. And negative 1 plus 3 is positive. So two negatives make a positive. Two other negatives make another positive. Then two positives, we are going to get all positives. All right, let's go with the next one. 1 is positive. 1 plus 6 is positive. 1 minus 6 is negative. 1 minus 2 is negative. 1 minus 4 is negative. 1 plus 3 is positive. So in this case, we get two negatives that make a positive times a negative is negatives times 3. Positives, well, in this case is negative. Let's go with the number 3. 3 is positive. 3 plus 6 is positive. 3 minus 6 is negative. 3 minus 2 is positive. 3 minus 4 is negative. And 3 plus 3 is positive. So in this case, two negatives make a positive times a bunch of positives. It's going to be positive. All right. Now let's look at this one, at the next one, and last one. So 5 is positive. 5 plus 6 is 11, which is positive. 5 minus 6 is negative. And then 5 minus 2 is positive. 5 minus 4 is positive, and 5 plus 3 is positive. So I only have one negative times a bunch of positive. That's going to be a negative, and I need one more. I forgot to do the last one. So I'm going to choose the number 7 as our test value. So 7 is itself positive. 7 plus 6 is positive. 7 minus 6 is positive. 7 minus 2 is positive. 7 minus 4 is positive. 7 plus 3 is positive. The product of all positives is positive. All right. So in this case, we are looking for this right here, okay? And in this case, that indicates that we look for the negative interval. So in this case, going from left to right, all right? So I'm going to write solution set. This is going to be the first one, which is this one right here, and then that one right here, and finally this one right there. All right, so let's see. -6, -3, all with parentheses, union 0 to 2, union 4 to 6. All right, and this is a good place to quit. This is for the end of this section 5.5, polynomial and rational inequalities. I'll see you on the next video.